Okay, 4.3, differentiation rules for sinusoidal functions. Let's start off with the example, differentiating y equals tangent of x. And I gave this problem to you at the end of the last lesson to see if you can determine the derivative yourselves. But here, let's take it up. So if you recall, tangent of x is the identity where you have sine of x divided by cosine of x. And so you have a function in the numerator, sine of x, and a function in the denominator, cosine of x. And to find its derivative, so if we want to find the derivative of tangent of x, we can apply the quotient rule. Okay, and if you recall the quotient rule is, well, it's if y is equal to f over g, then y prime would be the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator over the denominator squared. Okay, so if we apply this to tangent of x, then what we would get is y prime equals the derivative of the numerator, which is the derivative of sine x, and that is cosine of x, times the denominator, which is cosine of x, minus the numerator, sine of x, times the derivative of the denominator, so the derivative of cosine of x is negative sine of x, all divided by the denominator squared, cosine of x brackets squared. Okay, so what you might start to notice is that, well, you have a cosine times a cosine, which is a cosine squared, and you have a sine times a sine, which is a sine squared. Two negatives make a positive, so I have plus sine squared. And so the numerator just becomes something that looks like the Pythagorean identity. The Pythagorean identity says that if you have cosine squared of x plus sine squared x, that is equal to 1. Okay? And so we can replace the numerator with 1, and we still have the denominator cosine of x squared, or cosine squared x, and that's simply just one of the reciprocal identities. If you recall, secant of x is the reciprocal identity, the reciprocal of 1 over cosine. Okay, so when I look at 1 over cosine squared x, what I really have here is 1 over cosine of x times 1 over cosine of x. And what is that? That's just secant of x times secant of x. So that's secant of x times secant of x. Otherwise, we could just say it's secant squared. And that's your derivative of tangent of x. So that will be another common derivative you're going to see going forward in the future. So keep that in mind. You'll have to know that for the AP exam if you are writing the AP exam. All right. Find the derivatives with respect to x for each function with a chain rule. So let's apply the chain rule with trig functions. So recall chain rule. We have an outside function, right? So the cosine function is the outside function. Okay, and you treat the argument of cosine as the inside function. Okay, and so when I take the derivative of y prime, you take the derivative of the outside function first, so the derivative of cosine is negative sine. And whatever the argument is for the function y, you repeat that for your derivative. So the argument of sine is going to be 3x. And then you take the derivative of the inside, and the derivative of 3x is just 3, so times 3. And I can just rewrite this with the coefficient in front, so negative 3 times sine of 3x. It's always a good idea to keep your arguments in brackets. For the next question, y equals 2 sine of pi x. So the derivative is as follows, y prime, the coefficient of the 2 there can stay there, 2. Sine is your outside function, so the derivative of sine is cosine. Rewrite the inside argument there, pi x. And then you have to take the derivative of the inside, so the inside is a linear function, pi times x. Derivative of pi x is just pi, so times pi. And again, bring any constants, coefficients to the front. So 2 pi times cosine of pi x. Okay, cosine cubed of x. Now, what is cosine cubed of x? Cosine squared of x, cosine to the power 4 of x. I sometimes tell students, hey, you know what? It might be easier to see if you just rewrite it like this. Cosine of x cubed, right? Just as cosine, remember, cosine squared of x is just cosine times cosine. Okay? Or you could just say cosine in brackets squared. So do that here too. Cosine cubed of x would just be cosine x in brackets cubed. That way it's much more easy to see the chain rule, right? You have something cubed, that's your outside function, and the cosine x is your inside function, right? So y prime would be 3 comes to the front, rewrite the inside, cosine of x, and then the exponent reduces by 1, so it becomes a squared, and then multiply by the derivative of the inside. The derivative of cosine x is negative sine of x. And then to clean it up a little bit, just bring the negative to the front. So negative 3 times cosine squared x times sine of x. Okay, and then for the last one here, y equals 2 sine cubed x minus 4 cosine squared x. You have two terms here, y prime. The first term requires the chain rule. So think of sine cubed x, that's or sine x cubed. That's your outside, sine is your outside, the cubed is your outside function, right? So the 3 comes to the front, multiplied with the 2. So we'll have 6 here. Rewrite the inside function, sine of x, reduce the exponent by 1, so it's squared. And then multiply by the derivative of the inside function. The derivative of sine of x is cosine of x. Okay. And then you have minus, again, cosine is not your outside function, it's the squaring. The squaring is the outside function. So the 2 comes to the front of the cosine, so 2 times 4 is 8. Rewrite the inside, cosine of x. Instead of cosine of x squared, reduce the exponent by 1, so it just becomes 1. And then multiply by the derivative of the inside. The derivative of the inside is the derivative of cosine of x, which is negative sine of x. Okay. And again, if this is difficult to see, you may need to rewrite the question as 2 times sine of x in brackets cubed minus 4 times cosine of x in brackets squared. That might make the chain rule more apparent. Okay, so keep that in mind. And as far as the derivative goes, the only simplification we can make here is just the 2 negatives here. Let's make that plus. So plus 8 times, I'll write the sine x first, so sine x cosine of x. Okay, for the first term here, not much I can change here. We can just leave that as 6 times sine squared x cosine of x if I didn't want the brackets anymore. Okay, so just a remark on the if you have a function in the inside of your argument for the trig functions. Okay, so as far as our regular curriculum course goes in our textbook, mostly the arguments inside are linear functions. Okay, so you could have, so I'd say expect arguments that are functions I should say linear functions. Linear functions. So you'll notice that in the textbook there are practice problems with linear functions. Okay, so that could be in the form of mx plus b. Okay, or it may just be a coefficient only, right? 3x. Okay, or it could be, examples 3x, or it could be 5x minus 1. Okay, or you could use pi x, or we could use fractions, pi by 4, and a different variable, t. Okay, and then maybe more than minus 1. Okay, or maybe there's some brackets. So keep that in mind as we go through it. But it's also a good idea to look at other other kinds of functions as the argument, quadratic functions perhaps, cubic functions. Uh, as you progress toward getting closer to the AP exam, you will need to be comfortable with other kinds of functions as the argument. It could be exponential functions in the argument. Okay, for example, or other trig functions. Okay, but as far as our regular curriculum goes in our Chapter 4 test, we will just limit the argument to the trig functions as just either x as the variable x, or a simple linear function, as I just I just indicated right here on the screen. Okay, so you also have to, again, you still have to be familiar with using the chain rule. Okay, just like these examples show, and maybe even using the product rule, right? So here, the next example, product rule: x cubed times cosine of x, right? So y prime. What are my functions? I have a function x cubed and I have a function cosine of x. Okay, so a chain rule says take the derivative of the first function, x cubed has a derivative of 3x squared. Use brackets. Okay, times the second function, cosine of x, plus the first function, x cubed, times the derivative of the second function. The derivative of cosine of x is negative sine of x. Okay. Now, the question could be, well, do I simplify this? If there was an easy way to simplify it, like if there's anything you can notice that you can simplify it with, then yeah, simplify it. Like otherwise, for this particular question, this looks like, well, you can just do maybe just bring the minus sign here. So minus x cubed sine of x. Okay, and in the first term, I mean, you could just remove the brackets, 3x squared cosine of x. But, there's no common trig function that you can factor out. You could factor out an x squared if that becomes beneficial. Like you could do that, right? You could do an x squared, 3 times cosine of x minus x times sine of x. Okay, but it's not tremendously useful. Okay, so leaving it like this would be okay. The next question, y equals sine 4x times cosine squared x. Okay, again, using product rule. What is the first function? You got sine of 4x. Notice how the argument is a linear function, 4x, so you're going to use a chain rule here for that one. And the second function is a cosine squared x, where the cosine is the outside function. Okay, so be very careful here. Okay, maybe it's useful to kind of work it out first, right? If I define f of x to be the first function, sine of 4x, then its derivative f prime of x will be the derivative of sine, which is cosine, rewrite the argument 4x, and then multiply it by the derivative of the inside function, or the inside argument, which would just be 4. And I can put the 4 in the front. Okay. And then the second function, g of x, equals cosine squared x. And so g prime. Okay, now again, cosine squared x, you can write that as cosine of x in brackets squared, so that you can recognize you have to use the chain rule here. 2 comes to the front, rewrite the inside cosine of x, and then multiply by the derivative of the inside, so negative sine of x. Okay, now you have the pieces, put them together to find the derivative, y prime. Okay, so if you start off with the derivative of the first function, so 4 cosine 4x, multiplied by the second function, cosine squared x, okay, then plus the first function, so the first function is sine of 4x, times the derivative of the second function, which we established as 2 times cosine x times negative sine x. Yeah, I guess we should be using brackets here. Negative sine x. Okay. So that's it for this section. Okay. So again, I just want to reiterate, you have to memorize those key derivatives. Derivative of sine of x is equal to cosine of x. derivative with respect to x of cosine of x is equal to negative sine x. Okay, and you should be also familiar with the tangent function. So d by dx of tangent of x equals secant squared x. Okay. But the majority of the emphasis for our chapter test is going to be sine and cosine. Okay. Other things, perhaps, that I could cover. Let me just think for a moment. Yeah. Well, okay. I'll just say, yeah, you got to know these three derivatives for the chapter test. And I'm thinking, do I have to? No, I think that's about it. Okay. Well, if anything comes up, we'll cover it in the next class. Okay, that's it. That's the end of this video. The next lesson we'll be doing some application word/word problems, getting familiar with, again, with your radians measures, perhaps even some special angles. Okay, so keep that in mind as we keep going forward. And the chapter test will come up soon. Okay. All right, so that's it. That's the end of this video.